Good morning, students. We are going to see in Unit 5 Laplace transform. The subject is differential equations and Laplace transform 19 MA 205. Under this, we are going to see convolution theorem. Course outcome of this video: to evaluate Laplace transforms of elementary functions and to apply those concepts in solving linear second order ordinary differential equations with a constant coefficients. An objective of this video: to learn about convolution theorem and its application problems. Applications. Laplace transform is used to solve the time domain function by converting into frequency domain, and Laplace transformation which is easy to solve the problems in engineering applications. In engineering fields, it is used to convert the signal system in frequency domain for solving it on a simple and easy way. And it is also useful in electrical circuit, digital signal processing, nuclear physics, process controls, applications in probability, applications in physics, applications in power system loading frequency control, etc. Convolution theorem. Definition. The convolution of functions f of t and g of t, which is defined over an open interval 0, infinity, is f into g of t is equal to integral 0 to t f of u g of t minus u into du. There are two functions f of t and g of t, which is defined over an interval 0, infinity can be written in this way. Theorem. If f of s and g of s are the Laplace transforms of f of t and g of t, then L of f of t into g of t is equal to capital F of s into g of s. And in note, we can also write L inverse of capital F of s into g of s is equal to f of t into g of t. We will see first problem. Find L inverse of s square divided by s square plus a square, s square plus b square using convolution theorem. And first of all, the given function must be splitted into two functions. So f of s into g of s, we should write it as L inverse of f of s into L inverse of g of s. So here the function is s square divided by two functions. We will write s into s divided by s square plus a square into s square plus b square. Then split into two parts. L inverse of s by s square plus a square can be written as cos at, which is a formula, L inverse formula. Same way, here the b is constant, cos bt. And using convolution formula, what is a convolution formula? F of t into g of t can be written as integral 0 to t f of u g of t minus u. So this is your f of t. We are writing as f of u. G of t is cos bt. We have to write it as cos of b into t minus u into du. Now we should integrate this with respect to du. Using the formula cos a cos b formula, 1 by 2 cos of a plus b plus cos of a minus b formula. Now on integrating, we get 1 by 2 cos integration sine of a minus b into u plus bt divided by a minus b. U coefficient is a minus b, so on integration we are getting in the denominator. Sine of a plus b into u minus bt divided by a plus b. Apply the upper limit and lower limit. So we will get 4 terms. Taking LCM, we will get 2a sine at divided by a square minus b square minus 2b sine bt divided by a square minus b square. Again take LCM and take 2 commonly outside and cancel. We get the final answer for the first problem. Second question. Using convolution theorem, find L inverse of s by s square plus a square whole square. Denominator you are having, you can split into two terms, but in numerator you are having only one s. So which can be splitted as, this s can be written as s into 1 divided by denominator s square plus a square into s square plus a square. Now L inverse of s by s square plus a square, as I said in the previous problem, you have formula cos at. But here L inverse of 1 by s square plus a square, you don't have formula. But L inverse of a by s square plus a square formula is sin at. So we need to multiply a and divide by a. So 1 by a L inverse of a by s square plus a square, which is nothing but sine 80. This 1 by a, it is a constant, we'll keep that side. And cos 80 into sine 80 are the two functions. This is your f of t and sine 80 is g of t. Now applying convolution formula, f of t must be written in f of u, g of t must be written in g of t minus u within the integral. Now bring sine in the first, then cos au into du. So now sine 80 minus au plus sine 80 minus this one. And now still we have not integrated. After this minus au and plus au you cancel it. We get sine 80 plus sine of a into t minus 2u into du. So we have to integrate with respect to u. So sine 80 is constant with respect to u. So sine 80 into u minus sine integration is cos a into t minus 2u. U coefficient is minus 2 into a. Minus 2u actually a. So u coefficient is minus 2a in the denominator. Apply the limit 0 to t. So upper integral and minus upper limit minus lower limit on substituting. On simplification, we get these two terms will cancel. Finally, we get t into sine 80 divided by 2a. So we need this concept for third problem. What is integral 0 to t e power minus u cos 3u du? Using the formula integral e power ax cos bx dx is this formula. First of all, we should identify, compare the question. What is a equal to minus 1. And what is b equal to 3. What is x is equal to u. All three terms, all three values you replace in the formula, simplify, we will get the answer. Same way we have sine formula, integral e power ax sin bx dx. Here I have used the formula, substituted a value, b value, x value in the formula. Finally I got, but I didn't apply the limit. In the problem I have substituted this 0 to t in the third question. Third problem, find the Laplace inverse of 1 by s plus 1 into s square plus 9 using convolution theorem. Now, L inverse of f of s into g of s can be written as into product of two functions. So, this function also we can write into product 1 by s plus 1 into 1 by s square plus 9. And this 9 can be written as 3 square. So, L inverse of 1 by s plus 1 formula e power minus t into, here we have to apply sine formula, multiply and divide by 3. So 1 by 3 outside, 3 by s square plus 3 square is sine 3t formula. Apply the convolution formula, we get e power f of t is e power minus t, we write it as f of u, and g of t is sine 3t, we write it as sine of 3 into t minus u into du. Now, on expanding, 1 by 3 integral 0 to t e power minus u is outside. We have applied the formula sin a cos b minus cos a sin b formula. Then you split into two integral, and now it is of the form as I explained earlier, integral e power minus ax cos bx dx formula, e power ax sin bx dx formula. On applying these two terms, we will get these two results. Apply the limit 0 to t in the problem. Finally, we get sin 3t by 3 e power minus u by 10 into minus sin 3t minus 3 cos 3t minus 1 by 10 into minus 3. So, using all three problems are very important with the different types. Practice problems using those concepts. You can try first problem L inverse of s square by s square plus 4 s square plus 9 using convolution theorem, and the answer was given. And using convolution theorem, L inverse of 1 by s square plus a square whole square. Thank you, students.